another area, and I'll term it quantitative reliability. And I go back during the requirements development phase where for the space station, I mean, the team went to the specification, to the design specification, and the specification identified various modes that the system had to meet. And those modes were subsequently decomposed to capabilities and then to functions as it was broken down and decomposed to the lower specifications. And so we thought it would be appropriate to levy quantitative reliability requirements against the modes to drive in the inherent reliability we believe needed to have to increase our probability of success. And we established these and presented these to the boards, and the board disapproved them. And the rationale, and this was unique to the station, of course, was that at that time, even though we were in the requirements development phase, that the hardware was in most cases already designed and built. So there was a concern by program management that it would ultimately drive cost of the hardware. And again, cost is always a significant player, and rightfully so. You can't ignore it, but it's a significant player in what you do and what you don't do. On a program like the Constellation, and where you have your mission time in orbit is years or months and months and months, that to me there's significant value in performing a quantitative assessment and allow that quantitative assessment to, if nothing else, identify the weaknesses in design given the inherent reliability of the various parts of that analysis. And so, your cut set, of course, and so it's value added. It allows for the designers to understand weaknesses in the design, and if nothing else, to present them to the program for consideration. On the station program, we were successful in adding one of the quantitative reliability requirements in called microgravity reliability, and the program gave that requirement to us because that is the mission of the space station, to perform microgravity science. And while that requirement was not decomposed to the lower specs, it was more so treated as a goal. And I think what was real beneficial about levying that requirement and verifying to it is that we were able to identify weaknesses in the design or areas in the design or use hardware that, if it failed, or a combination of items that if failed, would result in loss of mission in terms of a 30-day microgravity period. And so we presented those to the program, and while the program did not accept our recommendations, ultimately we provided a product, an area of risk to the program, and that's key, in that it allowed management to make a conscientious decision on the risk acceptance, and that has occurred. And of course, that's always the best case versus not realizing the risk, is there no one accepting that risk. So the risk of the failures in ORUs was accepted. Again, we didn't receive any additional hardware on the program for it. It may have ultimately impacted some sparing that we needed in the event that it fails. But again, that's what we did on station, and if you apply that to the Constellation program, I think it's very, very key in being able to ensure that the mission is met by performing a good quantitative reliability analysis.